All right, this is section 10.6, day number 1 for Algebra 1B, and we're getting into some geometry now. And maybe this is something that you've seen before, but a right triangle, that means that there's one angle that's a right angle or 90 degrees. We can use this Pythagorean theorem, and that's going to relate all three of the sides to each other. So in other words, if this length is some length, A, and this is a length B, and this is a length C, we could say that A squared plus B squared equals C squared. Right, so there's just the general idea of that. Normally, when you see the Pythagorean theorem presented, the C is by itself. We just have to pay attention to make sure that we're using the hypotenuse, this biggest side, always by itself. So in this example, I could say that 10 squared plus 24 squared is equal to C squared. So this is how it sets up. Again, always this side, the one that's across from the right angle, which is called the hypotenuse, is by itself. You're going to want to use your calculator for this. 10 squared is 100. 24 squared, I can use my calculator for that. It's 576 equals C squared. Now we're going to add those together. So 100 plus 576. Oops, put that in the wrong. 100 plus 576 equals 676. So 676 is equal to C squared. And then to get from C squared to C, because C is what I really want, we have to take the square root of both sides. And that's why we're really doing this in this section in algebra, is because it relates back to the square roots. 676 is a big number. I could look to break it down, or probably want to try first to see if it is a perfect square, and it is. So the square root of 676 is 26. So C, this unknown length, is equal to 26. Next problem to the right looks like this. It is another right triangle, and we're trying to find B this time. B isn't the hypotenuse, so the way this one would set up is B squared, which is one of the legs, plus 7 squared, which is one of the other legs, is equal to the hypotenuse of 15 squared. So again, notice the 15, the big one, the one across from the right angle, is the one that's by itself. B squared plus, that's 49. 15 squared, I can use my calculator, or do 15 times 15, which is 225. Now I'll definitely go to my calculator because I'm subtracting 49 from both sides, right? That'll give us B squared by itself. So 225 minus 49 is 176. And now we'll take the square root of both sides because we want B, not B squared. And the square root of 176, unfortunately, is a decimal. So now I'm looking to break down 176. All right, I'm going to try for 4 first. 176 divided by 4. Good, went into it 44 times. And since 44 can be divided by 4 again, that means that 4 and that 4, 16 would go into it. 176 divided by 16 is 11. Great, so there's a good pair for us. Square root of 16 times the square root of 11. The square root of 16 is 4. 11 I can't do anything with, so 4, that unknown side, or B, the unknown side, is 4 square root of 11. Go ahead and pause the video for a moment. See if you can get number 3 set up. What I see on this one is that 6 squared plus 8 squared is equal to C squared, because again, C should have a right angle in here. These should all be right triangles. C is the hypotenuse. It's the one across from the right angle. Use my calculator. I can get those values. Add those together, 36 plus 64. And then one more step, take the square root of both sides, take the square root of 100, and we get that C equals 10. Again, these should both have right angles on them, because if they weren't right triangles, we wouldn't be able to do it. In number 4, again, see if you can set it up, pause the video, take it as far as you can, then you can check your answer. I would say a squared plus 12 squared is equal to 16 squared. And these have to be squared in order to work. So a squared plus 144, 16 squared is 256. Now subtract 144 from both sides. We get 112. Square root of 112 comes out to a decimal. Okay, so 112, again, 112 divided by 4 comes out evenly to 28. Since this is divisible by 4, and so is that one, I think that 16 should work. So 112 divided by 16 is 7. So when we break down the square root of 112, it's square root of 16 times the square root of 7. Square root of 16 is 4. So take the square root, and it simplifies to 4 root 7. I don't really like the problems when we get square roots like this or square roots like that. I'd rather have nice integer numbers for all of them. And so this is called a Pythagorean triple. When you have a right triangle and all 3 sides are integers, non-square roots, non-fractions, we call that a Pythagorean triple. So the question is, are these Pythagorean triples? I see that all 3 of those sides are integers. So yes. Integers, yes. 8, 15, 17, yes. 7, 24, 25, yes. Pythagorean triples, 7 squared plus 24 squared would be equal to 25 squared. In the next row, if you use Pythagorean theorem, this length would come out to 2 root 13. So no, this is not a Pythagorean triple because we don't want a radical. This one is. This one with Pythagorean theorem would have a length come out to 7 root 3. So no, that's not a Pythagorean triple. And this one, again, all 3 sides are integers. Yes, that means it is a Pythagorean triple. All right, so if you have a right triangle, you can use the Pythagorean theorem. Or the converse, if we're switching it, if a squared plus b squared equals c squared is true, if the 2 smaller sides squared and added together equal the big side squared, that would make it a right triangle. So in this one, this is my biggest side, so I'm going to check how is 9 squared plus 12 squared related to 16 squared. If they're equal, that's great. That means it is a right triangle. If they're not, then it's not a right triangle. So on my calculator, 9 squared plus 12 squared, this comes out to 225. And then going back to my calculator, 16 squared is 256. And I see that these 2 sides are not equal to each other. So 9 squared plus 12 squared does not equal 16 squared. So no, these are not the sides of a right triangle. What's probably happening here is we have a length of 9, a length of 12, and a length of 16. These are pretty close to each other. So this is pretty close to a right triangle, but it's not quite a right triangle. All right, next check. 30 squared plus 40 squared. How does that compare to 50 squared? So go ahead and use your calculator because we do have these big numbers and compare. 900 plus 1600 is 2500. Square the 50, that's also 2500. Yes, those are equal. So yes, these would be the sides of a right triangle. Go ahead and try number 7. Pause the video, try number 7. And number 7, these are definitely not equal to each other, so no, those would not make a right triangle.